me? Are you hearing me?
Yes, sir.
Yes, sir.
That's good. And the presentation is displayed to everyone.
Yes, sir.
All right. Just give me an information. Is there any foreigner in your class? Should I speak in English or Urdu?
Yes, sir. You should speak in English because there are six foreigners in our class.
Okay,
Yes,
that's
sir.
all right. This is all right. Okay, let's start. I have already shared the contents for the today's lecture, and I hope you have read all the contents. And let's start. Okay. So our subject is particle technology lab. This is the course, lab course I'm going to teach you. First of all, I would like to introduce myself. My name is Dr. Muhammad Shahzad, and I'm the assistant professor in mining engineering department. I'm serving here since 2009, and I did my PhD in processing, and processing is the subfield of particle technology. Particle technology is a very vast subject. There is a very vast scope of particle technology, and processing is the subfield of particle technology. I did my PhD in processing. It's more related to coal processing, and obviously I'm expert of mineral processing as well, because coal processing and mineral processing both are related to each other. More or less they are overlapping fields. So in today's lecture we are going to discuss what is particle technology, and I will share a list of experiments. Then I will describe those educational objectives, both learning outcomes and assessment tools. Normally, students are more concerned with the assessment tools, so I will describe it earlier at the start of the semester so that you should be well prepared for your assessments. And target PLOs, this is just for the information, but I think you are already familiar with your program learning outcomes, and there are 12 of them, and we will target some of them. Not a single course can never target all the PLOs, so that's why we will target only few of them. Mapping of PLOs with CLOs, that's not very important from your point of view, but it is important when it comes to your results uploading through the LMS. Then detailed plan for the whole semester. I will share how we are going to perform lab work in the lab, and schedule for instructions related to different experiments, recommended text and reference material, assessment criteria again, and then visiting hours and my contact info in case if you need to discuss anything during the official hours, you can contact me through my WhatsApp number. I will share my WhatsApp number in the end. And first of all, before discussing the intro of particle technology, I would like to review the previous courses. So we'll have a little bit discussion related to your courses which you have studied in your previous two semesters. So first of all, please tell me the names of the courses. Yeah, please raise your hand. You can see here a symbol on the top where there is a symbol of hand. Just click it and then you can give me the answer. I will call your identity here, which is I think in terms of your roll numbers, then you will answer me. Question is, please tell me the names of the courses you have studied in your previous 2 semesters. Name of courses, please. I'm asking name of courses, please. Yes, 38.
Sir, industrial stoichiometry,
All right.
fluid, or applied physics, health and safety at workplaces, chemical process industries, or mathematics, park studies, Islamiyat, Quran translation, computing fundamental, engineering drawing, physical and analytical chemistry.
All right. Okay, here the most relevant subject to particle technology, I think, is chemical processes. Am I right? This is the name of the course, chemical processes.
Industry.
Yes, sir.
Chemical process industry. All right. So let's discuss it. What you have studied in chemical process industry. Please share the contents. I'm talking about your subject chemical process industry. Please share the contents of that course which you have studied in your previous semester. Okay, 42. Go ahead.
Sir, in chemical process industries, we have learned about few of the equipments which are used in the industries, and we have also studied different types of processes which are used in industries.
All right. Let's talk about the processes. Give me any one of them. Processes.
Sir, in processes, we have the learned process of water industry. For example, we have studied about the acid industry, and we have studied about the different type and cement industries.
Okay. Anyone else who would like to add more processes? Anyone else other than 42?
Sugar industry as well.
Dear, please raise your hand first. 38. Now go ahead. 38. Sugar industry and yes, 38.
I think
Okay. Anyone else who would like to add more to the processes which are related to chemical engineering? Anyone, please?
Fertilizer industry.
Fertilizer industry, very right. More. I need more.
Paper and
Textile
pulp
industry.
industry.
Please. When I call the roll number, then you will speak. Right? Now, 35, please.
Paper and pulp industry.
Paper and pulp industry, very right. Next, please. Anyone else who would like to add? Yes, roll number 63. G. Go ahead, roll number 63. Okay, next. Roll number 11.
Also textile industry.
Textile industry, very good. Anyone else? Yes, roll number 49.
Surface coating industry or fertilizer or ammonia,
Very
soda ash,
right.
caustic soda industry.
Yeah, few of them are still missing. Yes, 54.
Sir, petroleum and pharmaceutical.
That's very good. More, yes. Okay, 54. 54, can you tell more?
सर पेंट इंडस्ट्री आती है आपकी और फूड इंडस्ट्रीज में भी बहुत होता है.
Very good, very good. Yes, roll number 11. Anything else you would like to add?
उससे मैंने बोलना था वो बोल दिया मैंने सर.
All right, all right. Roll number 49. Sorry, 54. 54. 49. All right.
Glass
This
manufacturing.
very right. That was missing. Glass manufacturing. That's good. That's good. All right. Let's now discuss the actual processes. Let's let's talk about the cement industry, right? Talk about cement industry. So I need you to describe the process of cement manufacturing. Process of cement manufacturing, please. Yes, roll number 12.
Dry process and wet process.
Okay, I need the elaboration of detailed process. Anyone, either dry process or wet process. Describe it in detail. Okay, anyone else who would like to describe the detailed process of cement manufacturing? You can choose anyone, whether a dry process or wet process. I need the details how the cement is manufactured. There are the different steps involved there. So I need you to describe those processes in sequence, please. Nobody? Didn't you read the process in detail? Yes, 49.
Sir, can you hear me?
Yes, I am hearing you.
In the wet process, basically we use the soft raw material, and while in the dry process we use hard material. In process, we grind the material in the presence of the water, while in dry process we didn't use the water. In wet process, the slurry is then fed into the rotary kilns for the manufacture of the cement, while the dry process, the crushed material is ground in dry and then it given to the kiln. Grinding is done in waterfall, means in the presence of water, as I told earlier, and in dry process there is no need of the water. Fuel consumption in the wet process is more, while in dry process is less. Um,
Please go ahead. I'm listening.
and the length of the rotary kiln in the dry process is about 300 to 400 feet, while in the dry process is 150 feet to 250 feet, and the cost of the insulation in wet process is high while in dry is less, and
Okay.
the loss of the raw material is present in the form of the flue gas in the wet processes, while in the form of the dust in the dry process.
Okay.
And
That.
the recovery of the heat from the wet process is less, while in dry process the recovery of heat is more.
That's really good. You have
That's
provided.
it.
That's good. You have provided a lot of information related to the process, and that's really good. However, I'm more interested in the descriptions of the processes which are being used at different stages of the mineral or different stages of the cement manufacturing. So here the row number 12 was here. Row number 12, would you like to describe the individual processes in detail? Those processes which are being used for the manufacture of cement industry. Okay, anyone who would like to describe the individual process in detail, which are being used at different steps of cement manufacturing? Anyone? Yes, roll number 11. Please go ahead, roll number 11.
Yes, sir. So first step is crushing and grinding of limestone and clay. In this step, we just crush the limestone into small size. Then there are there can be two steps. There is a wet step and dry step. In wet step, we add water to make slurry, and in dry step, we just pass on the limestone and clay in small sizes. And then there is second step, mixing of raw materials. In the mixing of raw materials, we just mix limestones and clay in a specific ratio. And if there is a wet process, we mix water and the solids in the specific ratio. The third one is burning. In the burning, we use a kiln. Uh, the kiln is of different sizes for the both processes. Uh, for the and the time for in the kiln is also different for the both processes. And then there is uh, and then
All right, dear. All right, that's really good. Thank you. Roll number 12. You would like to say something more related to the processes? Yes, please go ahead. Roll number 12. Yes, 12, please go ahead. Are you hearing me? Roll number 12. It's your turn. Okay, I think I can't hear you, row number 12, if you are speaking. I can't hear you. Okay, let's move on. Let's move on. So we were talking about the processes here. The question is, why do we need to crush the raw material? Why do we need to crush and grind the raw material? Question is, yes. Roll number 45. Roll number 45. Please raise your hand. 54. Yes, 45. Go ahead.
So that they can mix easily.
Anyone else who would like to add? Yes, roll number 58. 58. Go ahead. 58.
सर जो रॉ मटेरियल को इसलिए क्रश किया जाता है क्योंकि अगर हम
English please, because there are some foreigners who would like to listen to you. Yes.
Sir, we need to reduce the size of the raw material because it may, what do you call it, damage the crushers or the process. It may, there may be impurities that need to be removed after the crushing, and if not so, then it may cause some problems during the, what do you call it, separation.
All right. This is somewhat a different objective but this is not the prime objective here in case of cement manufacturing. Please, 54, you can give me any other answer, a more
Sir,
reasonable
to,
answer.
to increase the surface area.
Very right. Very right. That is the prime objective of crushing of raw material in cement manufacturing, because we want to increase the surface area. We want to increase the surface area of the particles. And when we are talking about the surface area of the particle, it means the total surface area of the unit mass. It is not the surface area of single particle. It is the surface area of unit mass. Let's say the unit mass is 1 kg. Yes, 96. Would you like to say something?
Yes.
Yes,
Also,
please.
sir, in normal size, it will consume more power in industry.
Uh, in what sense consume more power? In what sense?
I- If we didn't crush the soft material, it will consume more power.
All right, dear. This is somewhat different thing. It is if you are talking about the power. Power is related to different things, and each individual stage in the cement manufacturing have different parameters for the power consumption, right? So it's not directly related to overall process. It is related to the individual processes at different stages being which are being operated, right? So we will talk about the power consumption later. So I was talking about the surface area of the unit mass. Let's say the unit mass is 1 kg, and if you imagine a single particle of 1 kg, single particle of 1 kg, large size particle of 1 kg. So you can imagine the area exposed to the atmosphere, and that area there will be some specific value of the surface area of the particle which is exposed to the atmosphere. Then you crush that particle. That 1 kg particle is being crushed and ground into finer particles, so it will produce number of particles will be produced. And then if you measure the surface area of all particles and sum it up, then you will get the higher value of the surface area in case of fine particles as compared in case of coarse particles. Remember, the mass is the same. We are talking about the same mass, right? So 1 kg mass is there, and there is one particle at the coarser size, and we crushed and ground it to the finer particle. So what will happen by increasing the surface area? What will happen? It will increase the reaction sites. It will increase the reaction sites, and the reaction will be fast then. So we will get the products in shorter time. If we are increasing the reaction size, then the reaction will be fast, and we will get the products in shorter time. So it will affect the production of the plant. If we are getting the products faster, then the per day production will be more. So that's why we are doing all these things, because we want to increase the per day production. And just in case, if, for example, if we are using the coarser particles for the chemical reaction, it will take a very long time to complete the reaction. So the per day production will be very low. We will get very small amount of the products in a day if the particles are coarser during the time of reaction. That's why we need to crush the material. We need to grind the material to produce the powder form of the raw material, and that powder form will present larger surface size for the reaction, and in turn it will increase the reaction, you can say the reaction speed will be increased, and we will get more product in shorter time. So this is the primary objective of the crushing and grinding of the raw material, right? So I hope this point is clear to every one of you. Now, the next question. Where we are getting these raw material? From where? My question. Please answer. 96, you want to answer, or it is just that the hand is not removed from the previous discussion? Yes, now right. Okay. Question. From where we get the raw material? Yes, 54. So from mountains and rocks. Very right. And mountains and rocks, are they the source of every kind of raw material?
So clay is either used.
All right. So if we are talking about the cement industry, obviously there are different ingredients, and we are getting these ingredients from mountains. In other words, you can say that we are getting these ingredients from the earth, right? We are getting these ingredients from the earth. So what are the ingredients? In case of cement manufacturing, what are the raw material ingredients for cement manufacturing we are getting from the mountains? Yes, please. Answer, please. Row number 12.
The ingredients may be limestone, clay,
Right.
chalk, oxide, ores of iron, and sand, etc.
All right. Very right. Very right. So, yes, row number 12. Yes, it's done. All right. So there are different kind of oxides which are required for the cement manufacturing. But actually, what we get from the earth is basically the 3 to 4 types materials. Number one is the limestone. Limestone is naturally found in the form of mountains, or even it is present beneath the surface of the earth in a huge quantities. Especially in Pakistan, limestone is present in huge quantities. That's why we have number of cement industries. It is I think around 27 to 30, 27 to 28 cement industries are there in Pakistan. So this is because we have plenty of limestone. Then there comes the clay material, from where we can get the aluminium oxide, and sometimes the iron particles are also present in the clay material. So we can try to find out the clay, the type of the clay which contain the aluminium oxide as well as magnesium oxide and iron oxide. So these two, three oxides are obtained from the clay material, and obviously clay material is also extracted from the earth. Then there comes the third main ingredient, that is gypsum. From gypsum we get what we get from gypsum. What is the composition of gypsum? Can anyone tell me? What is the composition of gypsum?
Sir, calcium sulfate.
Very right. Who was this? Calcium sulfate. Who was this?
Sir,
Roll number
58.
58. Yeah. Okay. All right. Okay, dear. Let me rephrase the process of cement manufacturing, and then we will come towards the introduction of particle technology, and you will be going to relate the cement manufacturing process with the introduction of particle technology. In cement manufacturing process, we obtain the raw materials from the earth, and you know that it is in the form of mountains. So what we do, we actually blast those mountains, and during blasting, we obtain number of particles of varying size, and those sizes are large, sometimes greater than 1 meter, sometimes few particles during the blast which are produced are greater than 1 meter in size, and some of the particles may be 50 centimeter, 70 centimeter, 80 centimeter. So we need to crush those particles and ground them to the powder form so that we can increase the surface area. Here comes, when we extract the material, then we have to move those material towards the crusher. The crusher will not be at the same place from where we are extracting the material. It will be at some distance. So we need to move those materials to transport those blasted particles from the blasting side to the crusher side. And for this purpose, what we have different kinds of dumpers, larger trucks, and those trucks are used to transport material from the blasting side to the crusher side. And once the material is crushed in a crusher, then it is transported to the grinding machines, and that transportation mode is different. Now it is no more a truck, it is now the belt conveyor, because the distance between the crusher and grinding machine is relatively small. It is just few meters. These machines are installed side by side. So if we need to move the product of the crusher towards the grinding machine for further breakage of the particles into smaller form, then we need to utilize belt conveyor. Belt conveyor will transport crusher product to the grinding machine, and after that we need to transport the product of grinding mill to the kiln. Again, belt conveyor, different buckets, and there are different systems here. So sometimes belt conveyor, sometimes buckets are used to. There is a bucket system that is a continuous one, right? So it is used to transport grinding material, ground material to the kiln, right? But when we crush the material, it is not a single ingredient which is being crushed. It is the mixture of the ingredient. We extract limestone, we extract clay material. All these materials are put into the crusher simultaneously, and these materials are transported to the grinding machines in the form of mixture, and these mixtures are further properly mixed in the grinding machine. Grinding machine not only ground the particles but also mixes them properly. So after the mixing, the material is transported to the kiln, and where the chemical reactions take place, and then we get the clinker. Can anybody tell me the size of the clinker and the color of the clinker? Anybody? This is my question, please answer. My question is, can anybody tell me the size and color of the clinker? Are you familiar with the clinker? What is clinker? Yes, 58.
सर सिल्वर या ग्रेश टाइप का कलर होता है. The color is silver or grayish type.
And size?
Sir, most probably 5 to 25 mm.
5 to 25 mm. Okay, that's right. That's very right. Good. Actually, it's just few millimeters to 20 millimeters, sometimes 25 millimeters. That's right. This is the product obtaining from the kiln. Is producing cement in the form of clinker, Although it is not called cement yet, because we have to mix the gypsum in the later stages. After the formation of clinker, we ground the clinker, and then we mix the gypsum during the grinding, and then the cement is formed, right? Okay, one more question. You know, the reactions which are being in the kiln, those reactions take place at a very high temperature. Can anyone tell me those temperatures and how those temperatures are maintained inside the kiln? How? Yes, 58.
Sir, almost 1450 degrees Celsius temperature is there, and it's maintained by dry blowers inside.
Sorry, repeat the temperature.
1450 degrees Celsius.
Okay, that's right. But there are different temperature zones within the kiln. Can you describe those temperature zones and their temperatures? Anyone? The temperature throughout the kiln is not uniform. It's a different at different place, and there are some temperature zones within the kiln. Can you describe the? Can you give me the value of the temperature in each zone? All right. Initially it is 1000 degrees Celsius, then in the next zone it is 1200 to 1300 degrees Celsius, in the next one it is 14 to 1600 degrees Celsius. There are sometimes three stages or sometimes four zones within a kiln. So the last one is the third one is the 1600 degrees Celsius, and the fourth one, in the fourth zone temperature gets down, it becomes lower. So we need to maintain those temperature inside the kiln. You were saying that we use dry blower. Why do we need dry blower? What will they do? They are not going to produce that temperature. So what will produce that temperature inside the kiln? Okay, that's enough. Normally, cement industries use coal particles. You know that coal is the fuel. So, cement industries are using coal particles, and these coal particles are mixed with the raw materials. They are ground simultaneously along with the other raw materials in the same machines, and then all the material, including limestone, clay materials, and coal particles, they are all in fine or powder form, and they are all being injected into the kiln at the same time, and the coal particles, they are burned, and during burning they produce heat, right? They produce heat, and that heat is being utilized to maintain a temperature within each zone. So the amount of the coal material and the quality of the coal material will maintain a certain temperature within each zone, right? So these are the things I want you to remember while discussing the introduction to particle technology. So that's it. That's the review of the previous subjects, and I did it because I want you to give you a broader picture when we are going to study the particle technology subject, right? So now let's come to our main subject, main course, that is the particle technology. I want you to define particle technology, please. What is particle technology? What do you think particle technology is? Just give me your guess. Just give me your understanding. What do you understand by the word particle technology? Yes, 42.
Sir, I think maybe processing of particles.
Processing of particles, that's very right. This is one, you can say this is one of the subfield of particle technology, right? Anyone else? Processing of particles is right because it comes under the scope of particle technology. Next, anything else? '96. Yes, '96. Please go ahead.
That science who study the behavior of solid, the bulk.
This is very right too, because the studying of the behavior of particles in the form of bulk is also included in particle technology. Okay, that's right. More, I need more.
There is a related the handling and processing
Who
in
is this? Who is this? Who is this? Roll number? Who is this? 100. 100, are you speaking?
Yes, sir.
Please raise your hand first, and then I will call, and then you will speak. All right? Now,
Okay.
you go ahead. You go ahead, 100. Please speak.
There is a related to the handling and processing the practicals.
Very right. Particle technology is also related to the handling and processing of the particles, right?
Yes.
Okay. Anyone else who would like to add few things more? Roll number 11. Yes.
So separation of particles.
Very right. Separation of particles. Basically, the processing and separation of particles, they are more or less same things. You can say separation of particles. Very right. Okay. Row number 9. Yes.
The study of behavior of particles in different.
Sorry, I can't hear you. Repeat. Row number 9. Repeat. Okay, 96. Do you want to add something?
No, sir. Sorry, but
Okay.
just forget
Okay.
my hand.
Okay, please remove your hand. Row number 12. Row number 12.
Sir, the particle technology includes to find the relationship between individual particles, properties, and their collective behavior.
Very right. Individual particles properties and the collective behavior, all these things are included in the scope of particle technology. Very right. Still there are things which are missing. Anyone else would like to add those things? Row number 39. Please go ahead. 39. 39. You are up. 39.
Technology related to particles and powders. Handling
Parti-
of particles and powders.
that's why it's already been said, but that's all right. Handling of powders, handling of particles, right?
Technology related to handling particles and powders.
Very right. That's right. Technologies which are being used to handling of particles and powders. Yes, row number 29. 29, you go ahead.
Particle technology is all about the properties of the particle and the processes that we do on it to get the required results. Okay, sir.
All right, row number 24.
Sir, anything that is related to the processing, including method, procedure, equipments, during procedures and process of particles.
Okay, that's right. That's right. Let's see the formal definition of the particle technology. Right? Particle technology is the branch of science. Uh, okay. Can you hear me? Are you listening me? Is my voice clear?
Yes, sir.
Yes, sir.
All right. So particle technology is the branch of science and engineering which deals with the production, handling, modification, and use of a wide variety of particulate materials, both wet or dry, in sizes ranging from nanometer to centimeters. Okay. So here there are four basic things. The number one is the production of particles. When we talk about the production, there are many things which are involved in the production means it may be related to the production of the raw material. For example, if we are extracting the material from the earth, then all the processes which are involved in extraction of the material from the earth, they will come under particle technology, because we are dealing with the particles. When we blast the mountain, particles are produced. Doesn't matter what is the size of the particle, although we measure the size of the particles there, and we use the size to optimize the process of blasting, but what we are doing there, we are producing particles from the earth, right? So this is the production of one kind, but there are many other productions as well. For example, if we are using a steel making plant, we extract the material from earth and then we process it. For example, we are processing iron ore, and when we process iron ore, then we get the final product in the form of particles, and these particles will have different size as compared to the raw materials, right? So these are also this is also production. When you get a product from a processing unit, that is also production. So all the things which are included in the processing units, they will come under the scope of particle technology, right? So these are some of the things. So you can also relate it to many industries, pharmaceutical industries. We are producing medicines in the form of powder, then we are producing tablets. These are also particles, or tablets are made of fine or ultra fine particles. So this is the production, we are producing those particles. Then next comes the handling means transportation and storage. Sometimes we need to store the material, and if the size of the particle is different, then the method of storing will be different. For example, if there are very large particles, in case of production of the raw material for cement manufacturing, the particles we are getting from the earth, they are very large. So how we store them? We basically just kept them in open piles. The piles are present in open atmosphere, right? There is no need to cover them, because they are okay, because we need to see the cost as well, right? So if the particles are very large and they are not reactive with the atmosphere includes air and water as well. Moisture is also present in the air, that. And if they are not reactive, then there is no need to cover them. Then there is no need to erect sheds or rooms or storage units. Just keep them in open atmosphere in the form of large piles. And these large piles sometimes contains millions of tons of material. Lakhs of tons of material is present there. Lakhs of tons of materials is being stored in the form of piles, large piles, right? Similarly, when the material size is smaller, let's say it's in the palm, then sometimes we can utilize pile as well. But in that case, the design of the pile is different. In case of powder form, the design of the pile is different if we are using pile as a design. But there are some silos as well, large buckets, very large drums. They are called silos, and we store powder form material in the silos. Right? So there are different methods, and we need to know all the methods. Engineer, we are studying engineering. Being an engineer, we should be familiar all types of storage processes, all types of production processes which are related to your engineering. Not everyone's engineering, just your engineering. And we should be familiar with their applications and limitations. We should be familiar with the advantages and disadvantages. We should be familiar which type will be used in which conditions, or which type will be more economical in which conditions, right? So these things should be studied thoroughly by all of you. Then there comes the modification, right? What is the modification? Can anyone tell me what is the modification? Okay, I'm going to give you an example. When a pharmaceutical industry, okay, 24, you want to say something? 24, 24. All right. When pharmaceutical industry produce medicine, mostly it is in the form of very small particles, very fine particles, or you can say it is in the form of powder, right? Very small grains. Because these medicines are produced through the process of crystallization, and some chemical reactions are being taking place, and then these chemical reactions are producing some crystals or some very fine grains of size of micrometers. But actually, we are using those medicines in the form of tablets. We cannot use those materials in the form of powder. We need to make a tablet. Then after that, after the production of the powder form in bulk material, in the bulk form, when the medicine is produced, it is produced in the bulk form. Per day, you can say 1 ton of material, 2 ton of material, or 10 ton of powder material is being produced, and we need to convert it into tablets. And there comes a process of mechanical uh, briquetting that is being used to produce tablets from that powder. Right? You know that tablets is a relatively hard form, solid form. Although the powder is also solid form, but it is in loose form, and tablet is in the compact form. Compact form. So we need to modify those products which are produced from the plant, and we need to convert them into tablets so that it can be used by the consumer, used by the market. It can be sold in the market in appropriate form. That is the modification. And then there comes the use of variety of particulate material. Actually, it is related, mostly it is related to the new materials, or old materials as well. So whenever we are going to produce a new product, we normally focus to define its use as well. how we are going to use and where we are going to use that material. Whatever you produce during the research, different scientists they are continuously producing new type of materials, and then after that, two important things, two important kind of studies are being done. The first one is to characterize that material. What are the properties, basic properties of those materials, and how, the second one, how we can use that material for the benefit of humanity, for the benefit of money as well, because the basic purpose is to commercialize that product. So we need to see how this material can be used in different forms during routine life by the persons or for any use, and how we can sell it. So we need to define the use as well. And these studies involve different sizes, centimeters to nanometers. Although the nanometer field is relatively a new field, and it is treated as a separate field. Mostly we use particles in the range of a few micrometers to centimeters in routine. In routine at the industrial level, we are handling materials in the sizes ranging from few micrometers to centimeters. The scope of particle technology is clear to everyone, and the definition and the things which are related, these are clear to everyone. Okay. Next, the processes which are involved in particles. These processes include bulk storage, crushing and grinding of the materials, particle size separation. What do you mean by particle size separation? Can anyone tell me? Yes, roll number 12.
Separation on the basis of particle size.
That is sizing. That is not particle size. Particle separation. Sorry. This is all right. Particle size separation is the yes. Your answer is right. One thing is particle size separation, and the other thing is the separation. And now I'm talking about the separation, or you can see the processing. So what do you mean by particle separation or processing? Yes, roll number 99. Are simple separation processes, and these separation processes include, here you can see tabling, and these include flotation, magnetic separation, electrostatic precipitation. These processes, they are based on different principles, but the main objective of all these processes is the same: to separate valuable mineral from non-valuable mineral. Size analysis, we separate the particles on the basis of their sizes so that we can utilize for different purposes. And we will discuss these things in detail later as well. Powder metallurgy, nanotechnology, particle characterization by shape and others. Particle characterization is also the part of the particle technology. Particle characterization means to measure the properties of particles like its size, its shape, its composition, its melting point, boiling point, and all the other properties which are important for its application at different industrial levels, right? So we need to measure all those characteristics of the particle, and we need to know all the techniques which are being used to measure all those properties, right? So being a particle technologist, we should be familiar with all those techniques, and we should have a practice, hand-on practice on those techniques to measure all those properties of the particles, right? There comes the applications of particle technology in different industries. These includes chemical industries, petrochemical industry, agricultural, food, pharmaceuticals, mineral processing, advanced materials, energy, and environment. If I am going to explain all these industries, particularly the applications of the particle technology in these industries with the help of example, it will take pretty much time, but I'm not going to do it. It's your assignment. You are going to find the specific applications of particle technology in chemical industry. We have discussed the cement industry, and in cement industry we are dealing with particles. We have discussed the applications. All the machines which are being used to crush the material, they comes under the particle technology. All the processes which are dealing with the particles, their modification, their handling, their production, they all comes under the scope of particle technology. Similarly, you need to find the specific application of particle technology in petrochemical, agriculture, food industry, pharmaceutical industry. Okay, I can tell you uh, one particular example in food industry. We are getting wheat. Are you familiar with the wheat? We are getting wheat from crops, from wheat crops, right? In order to eat wheat, we need to grind it into powder form. We get flour by grinding the wheat particles, and you know that the wheat grains are few millimeters large grains, few millimeters, and we need to convert it into finer form. The machines which are being used to grind those wheat particles and convert it into flour, these machines comes under the scope of particle technology, because we are dealing with the grains, we are dealing with the particles right here. So this is the specific example of the particle technology in food industry. Similarly, you need to find the applications, specific applications of particle technology in all these industries. And believe me, as a chemical engineer, you have applications or jobs in all those industries. So you can fit any of those industries. So basically, you should be familiar with the applications and how you are going to apply it, and you should have an hand-on experience on those things, and in the lab we are going to do those things. Any question so far? Any question? Okay dear, any question so far?
No, sir.
No question. Okay, what we are going to do in this lab? Basically, we have all the machinery related to sizing, tabling, flotation, magnetic separation, electrostatic precipitation, right? And we have machinery related to crushing and grinding. In the lab, we are going to cover these first two things: crushing and grinding and particle size separation. We are going to perform experiments on those machines. We are going to study those machines. These machines, tabling, flotation, this does not come under the scope of chemical engineering because it comes under the scope of mining engineering. If I give you an example of cement industry, there are different stages. The first stage is the production of raw material from the earth. That is not the work of a chemical engineer. They will be a mining engineer. Mining engineer is extracting the raw material from the earth, and the mining engineer is providing that material, and then the same mining engineer is dealing with the crusher as well, primary crusher. Then there comes the other machinery, and those machines come under the scope of chemical engineer. Right? So you don't need to study tabling, flotation, because that these are the separation processes which are being supervised by the mining engineer or metallurgical engineer. Your work starts from here. Your work starts at the main plant, and the main plant contains crushing units, grinding units, separation units, and then obviously chemical reaction chambers, and then the other units after the handling chambers, right? All things to the scope comes under the scope of a chemical engineer. So in this lab, we are going to study these initial processes: crushing and grinding and particle size separation, right? So these are our main targets, right? And how we are going to study it, there is a list of experiment I'm going to share. We will perform three crushing tests on three different machines, and then we will perform grinding test and then sizing test. There will be nine. There will be nine experiments, and three related to crushing, three related to grinding, and three related to sizing. The list is given here. We will perform tests on each. These machines are being used at industrial level. So we are going to perform experiments on these machines. Our main focus, what will be the main focus? We are going to study that machine and then perform an experiment. The main focus is to measure the performance parameters. In the lab, you are going to measure the performance parameters, and the techniques we are going to use to measure the performance of these machines in the lab are used, the same techniques are used at industrial level, right? So if you learn those techniques here, you can do the same at the industrial level. Obviously, the scale is different. Here in our lab, we have our smaller units, but at industrial level, they are larger units. The scale is different, but the technique is same. So we are going to learn about how to measure the performance of these machines at laboratory level, at industrial level. Also, the other
सर आपकी आवाज नहीं आ रही